Hi, everyone. Thank you for joining us today for the um, live stream of the solution walkthroughs. The, sorry, I'm trying to listen to myself just to make sure everything's working. Um, so today we're going to be walking through the solutions for the MetaCTF Flash CTF from 2 weeks ago for the April CTF. I'm going to wait a few more minutes just to make sure everybody who wants to join in joins. And I guess let me make an announcement on Discord as well. But we'll get started soon. Yeah, and if you have any questions, feel free to post in the YouTube chat. Feel free to send me a message on Discord. I'm going to be monitoring the Anti-7 training Discord, so let me paste the link to that as well. All right, well, I think we can get started. Can somebody in chat just message something so I know everything's working? Doesn't matter what it is. I'll share my screen. All right, so the Flash CTF took place on April 26th, which is actually just last week. We had a pretty good turnout, about 1,000 participants. But we try to have 5 challenges that cover 5 different categories in each of these CTFs, and we try to switch up the difficulties. So you can see the order in which we had the difficulties this time. So reverse engineering one was the easiest, then we had the web exploitation one, cryptography, forensics, and binary exploitation. So all of these challenges are still available. You can access them by going to mctf.io/APR 2024. And you'll be able to register for the competition, for this competition, and see all the challenges. All of the solutions have already been published as well. So if you go to the landing page, click the write-ups button right in the middle, you'll see all the different PDF solutions for all these different challenges, both written by us and by some of the participants. Let's see, so let's get started. So the first question is called Architecture Astronaut. It's a reverse engineering challenge, supposed to be pretty easy. And it says, we recovered this executable from a device, but we can't figure out how to make the program run. We suspect the code was compiled for a system with a different CPU architecture. Can you figure out which architecture it was compiled for? The flag is the name of the architecture. You don't need to run or take apart the executable. So to summarize, this challenge is giving us some kind of executable. An executable or binary is just a word used to describe programs that have been compiled, from source code into some kind of, machine readable, machine understandable program. So usually take C, use a tool like GCC to compile it to a binary. There are Linux executables, there are Windows executables, and they take this source code and they compile it into something that a machine can understand. But there are different types of architectures. There are different types of processors that run these, the computers can have. And so when you compile a program, you need to know which processor type you're compiling for. The two most common ones are Intel architecture and ARM. And so you'll often see that some programs that have been compiled for Intel are not supported by ARM processors. For example, you might write a program in C and compile it for Linux, for like your Windows machine, or your Linux machine running on an Intel processor, and then you try to copy it over to your Mac laptop. It's not going to work. Um, and so what we have to do for this challenge is figure out what is the architecture that this specific binary was compiled for. And it says here that you don't actually need to take it apart or do anything with it. So all we have to do is figure out the architecture. And there are several different ways to do that. Um, I, I use this tool all the time, but I think the easiest option is to use a tool called CyberChef. It has a recipe called, I think, elf info. And elf is it's an executable, I think, executable length file. What does elf stand for? Nope. IT. Executable linkable format. So it's a type of executable specifically most commonly used on Linux systems. And if I simply upload this executable into CyberChef and ask it to pull this information for me, it's going to tell me that it was compiled for the Tensilica extensor architecture. So this is the answer. Another way you could do this is by using the file tool. So I'm going to open up my Kali VM. And download the file. Why is that working? I think it thinks my, okay, there it is. So I'm going to download the file, and I'm going to use the file command to tell me what it is. And so a file is a built-in Linux command that looks at the magic bytes and the file headers to tell you information about the file. And it tells you right here that it's an executable compiled for the Tensilica extensor architecture. And I think the creator would have accepted either of these words. Any string that would contain one of these two words would have been accepted as the correct flag. And if I remember correctly, I think the solution included another way of solving this challenge. Let me see. CyberShell file. Okay, yeah. So there are also a lot of other online tools that let you, tell you give information about a file. And so you could have used those, but I think these two are the easiest solutions. I think there's a slight delay between the stream and the comments, between what I'm recording and what you see. So if you have any questions, let me know. I'll start going through the second challenge, but can always come back and answer questions to this one as well. Yeah, Cheddar says that there's a readelf tool on Linux as well. Let's see if I have it. Yep. Let's look at. I guess let's try readelf-h. Nice. Yep. So it's going to tell us the same information as the CyberChef told us. I wonder if that's what it's trying to do in here. I'm just going to replicate the output of this command. But readelf is another tool that I've used. All right. Let me know if you have any questions, and I'll move on to the next challenge. So the next one was a web exploitation challenge called Login Query. I'm trying to log into my online crypto wallet, but I forgot my password. There isn't a password reset feature, and I can't reach support. can you help me log in and get the flag? My username is Jim404, and you can download the source code here. So if we go to the link, we see a something that looks like it's supposed to be a crypto website. And we have a login functionality. If we enter something, it tells us, tries to log you in. So you could start by looking directly at the source code that was provided. I like to start just by looking at the source code of the page that we're given. And we can see right here that when you click the login button, it's going to call the login function, and the login function is going to send a request to /login. It's going to send your username and password, and it's going to check to see if there was an error logging you in, or otherwise it's going to log you in and replace all this information. And if we open up Browser Developer Tools, click the Network tab, and try logging in again, we will see that's exactly what's happening. A post request is being sent to /login with the following payload, and in our case, there is an error with the message of login failed, please try again. But we do see something interesting. Something that suspiciously looks like a SQL query. And it tells us exactly what query was run to produce this result. So this will come in handy later, but I'm going to download the source code and show you kind of how what the vulnerability is in the code. It looks like I already have it extracted, so I'm going to open it up in VS Code. Let's see if I can zoom in. So looking at the application, we see we're given a Docker file. This Docker file tells us that we're pulling the Ubuntu image, we're installing Python, we're installing Python pip, we're installing Python Flask. Python Flask is a kind of a web server written in Python. It's meant to be pretty simple and pretty lightweight. So this gives us an idea of what technologies are used to deploy this application. It creates a directory called /app. It moves the contents of this directory into /app, and then it changes the permissions of this directory such that the user that we add later, called app, is not going to be able to modify the files, but they are going to be able to read the files and list the files. 555 gives you execute and read permissions, and you need to execute permissions in order to be able to list directories. Yeah, and so the only reason, if you were deploying this somewhere else, usually this would not be necessary, but the reason we're including this here is to make sure that you aren't able to actually modify the application for other users, since we only have one instance of the application for everybody. And the challenge gives you the ability to run SQL queries, exploit the application, and we don't want you to, accidentally modifying the application and breaking it for other users. And then finally, we start the container by running this Python file, app.py, using Python 3. So if I go to this Python file, we're going to see there's the /root, which is the same one we see right here. It's just the home directory, not the home directory, just the root of the website. And all it does is it returns the contents of the index.html. And that's exactly what we see on the website when we load the page. We also see that there's a /login directory. Not directory, I keep using that word. URI, I think is a better term. And it takes in the data that you provided. It pulls out the username from the data that was sent. It pulls out the password from the data that was sent, computes the MD5 hash of it, and then it runs this query. It opens up the database stored in the DB SQLite file, and it selects the username, the Bitcoin address, Bitcoin key, and balance from the users table, where username equals this username and password equals this password hash. So this is a, it's a valid way to generate a query, but it's very much vulnerable to something called SQL injection. Essentially, what's happening here is if you are entering a user, if you're a regular user with a regular username that doesn't have any special characters, for example, admin, this will simply reduce to something that looks like this. The query is going to contain a statement that says where username equals admin. However, if your username is something more malicious that contains special characters, you can actually modify the execution of this query and and change the results and make it do things that the developer did not intend it to do. So, for example, if my username is end quote or quote one quote equals quote one, if I replace my username with this payload, the query is going to become where username equals empty string or one equals one, which is always true, and password hash equals whatever it is. So the issue here is that instead of just selecting the row with a specific username and password, it's going to select every single row because this always returns to true. And so this entire statement after the where always returns true as well. Looks like we had a question. I think this question came from Discord, where somebody's asking about the presentation. So there was another stream 2 hours ago, so I assume it was for that. Yeah, and the password hash field is not vulnerable because whatever input you provide is going to get converted to an MD5 hash, which only contains hexadecimal characters. And there is no way you can make a SQL injection payload out of just the hexadecimal characters. So that's part one. We figured out how to run, how to exploit this application. And if we go back and actually specify this payload, close the string or one equals one and enter any password, it's going to say login failed. Not true. I wonder if something happened to the application. Let's see. Let's look at the debug statement. Username equals one and password. Yeah, so I'm not sure why that query didn't work from the start. I'll have to go back and look. But essentially what I did is I commented out the rest of the query. I guess it doesn't give me the debug statement, but I modified the query to also include to close this one, add a semicolon and add dash dash. And what this means is that this query ends and dash dash is a comment. So essentially what happens is everything after this statement gets ignored. And I suspect the reason my query didn't work the first time is maybe the order of operations. It computes or and then it computes or and end on the same kind of level of priority. And so since our password hash doesn't match, it denies us. Yeah. So I commented out the rest of the query to let us log in. So we were able to successfully log in as an admin, but that is not what the challenge is asking us to do. We're supposed to log in as Jim404, and because we logged in as admin, we don't see the flag. So the way you would fix that is you would have to modify your payload a little bit to actually include the username as part of the query itself. So if I type Jim404 and I comment out the rest of the query and I type any password, it's going to log us in as Jim and give us the flag. The reason it wasn't working the first time is because this query fetches only one row. So even though we're selecting every single row from the database, it only fetches the first one. And admin has the lowest ID, and that's why we're logged in as admin as opposed to the user that we want to log in as. All right. If you have any questions about this challenge, let me know. I'm going to move on to the next challenge. All right, lost luggage. It's a cryptography challenge with 200 points, and it says, I need to get into this archive, but I forgot the password for it as well. All I remember is the same 4-digit PIN I used in my luggage lock. So we're given a some kind of zip file that it says I forgot the password for it. So you know, you would suspect that it's password protected. So if I try opening up the zip and looking at the flag, it's going to ask me for the password. So this is a relatively straightforward hash cracking, password cracking challenge. There are a lot of different tools that will let you do this, but I think John or Hashcat would be the two easiest ones. And I'm going to show you how to use John or John the Ripper to crack this hash. So I'm going to copy the link. I'm going to go back to my Kali VM, and I'm going to just make a directory and download this file. So John is a pretty well-known hash cracking tool, and it comes with a lot of utilities that let you convert different, extract hashes out of different files. So for example, this zip, it doesn't make sense. John can't open the zip file and try a bunch of passwords directly. So what it does is it extracts the password hash out of the zip file and then it tries executing commands against that. So there's a utility called zip2john that I'm going to specify the zip file. And if I just type this command as is, it's going to produce the following hash, pkzip hash. So I'm going to take this, the output of this command and store it to a file called hashes.txt. We're given a hint that this password is a 4-digit PIN. You could use that. For example, if you're writing your own Python script or Go script, whatever, to manually crack this password, the zip password, it's helpful to know that it's just a 4-digit PIN. In this case, the default word list for John includes all of those passwords. So all I'm going to do is just type John hashes.txt, where hashes.txt is the hashes like to crack. Luggage. Let's see. Yeah. Let me look at this. I literally did this a few minutes ago. Let me look at my history. I'm not sure why it's not working this time. John hashes.txt. Yeah, it worked last time. Let's try this again. Maybe since John already has it saved somewhere in memory, it just doesn't want to crack it again. But I'm going to extract the hashes again. And I'm going to do John hashes.to.txt. Okay, yeah. So I think I think because I ran this command just a few minutes ago, it's already it's not letting me run it again. You might have it somewhere. No, I don't I don't need to specify a Word file. If I just, well, I cleared my history, so that doesn't help. Um, but it automatically loads um, it should automatically load a word list, the default one. Let me try going to this directory. Where did I save this? Okay, well, um, if you look at the solution, I think the password was like 7 something. Yeah, all you have to do is just run John, and it's supposed to automatically load the default password list. And so if you crack it, it's going to tell you the password is 7123. So all we have to do now is open up that file again, enter the password, and it's going to give us um, the flag. Yep. Let me see if I can, maybe there's something in the .john directory. Yeah, it says I cracked it. I'm just not sure where it saved the results. Okay. All right, so I'm going to move on to the next challenge. But once again, if you want to come back to the solution, you can find the write-ups link from the landing page, and you can read these solutions from here. So the next challenge is a forensics challenge called Obnoxious Offset, and it says, dang, I really messed up this flash drive. I should probably have my GParty privileges taken away. Anyways, the flag is on the second partition in this disk image. So if we download this file, it's called obnoxious.img, and I'm going to, you know, I can open this file in the hex editor and in some other tool. I'm going to copy this file onto my VM. I'm using wget. So wget is a Linux command line tool that lets you download files from a URL or from the internet. And I'm just copying the link from here and pasting it in here and downloads it into the folder that I specify. So I'm going to use the file command again to tell me what obnoxious.img is. And it tells me that it's a DOS MBR boot sector, partition 1, and it has a partition 2. Yeah, so it looks like it's a disk image that has 2 partitions that start right here and that start right here. So there are a few different ways you can solve this challenge. One is you can use a tool like Autopsy to just analyze the disk. I'm going to use something called a loop device on Linux. Essentially, it's a technology or tool that lets you simulate like hard drives, simulate disks from a file. So, for example, I have this file. I can mount it as if it was a device on my machine, and interact with it as if it was, a folder on a disk. And so, for that, I'm going to create a. I'm going to refer to the solution. Yeah, so I can use a tool called fdisk to analyze the disk. You can skip this step because we kind of already did the same thing with the file command. But we can once again see the different partitions on this image and the type of master boot record that it has. So the next thing I'm going to do is I'm going to set up a loop disk. So I have to be a sudo. And use the command called low setups. So I'm going to specify the flag -p. And the reason I specified the flag -p is to tell this tool to take the partitions into consideration. Otherwise, if I exclude this flag, it's going to simply mount this entire file as a disk, and it's not going to be able to, it's not going to see the partitions, and so you won't be able to interact with it. But I'm going to mount this file. I think if I just specify -f, it's going to find the first loop device that's available. And I'm going to mount obnoxious.img. Let's see, I think I need to do sudo low setup -a to list them. Yeah, and so we see that it was mounted to device loop 1. So the next thing I'm going to do is I'm going to create a directory where I'm going to mount this file to. I'm just going to do sudo make directory mount obn. And then I'm going to do sudo mount dev loop 1, loop 1, partition. I think it said that the flag was on the second partition. So I'm going to mount the second partition into this folder. Yeah, and so now all we have to do is go to that directory and look around. And here we see that there are two folders. One starts with T, the other one starts with M. So I'm going to list them. T, H, M. Yeah, so as you can probably see, these directories are starting to put together a word. And the reason we did that is because we didn't want you to simply be able, if we just put the directory name as the flag, you would have been able to use strings to just pull out the flag directly from the file. And so this way we kind of scrambled the flag, but all I have to do is, for example, type change directory M, and then just keep holding tab to spell out the flag. Yep, here it is. MetaCTF, it's a partition table party. You can also use the find command, as you can see in the solution. So I'm going to just copy this directly from the solution. I'm going to change this to OBN. And it's going to list, so it's going to recursively list the contents of all the different directories and tell you kind of what they are. Yep, so here's the flag. Any questions? Let's see. We can always come back to this one. Well, one thing I forgot to mention about the web exploitation challenge from earlier, and the only reason I found is because somebody else submitted a solution that I didn't find beforehand. The intended solution for this challenge was to use SQL injection. But it turns out that when you delete a row from a SQLite table, the data still persists in the SQLite file, I guess, unless you completely resave it, optimize it. And so the original flag was in the SQL database file, even though it wasn't in the actual database, it was just left over in the file. And so you would have been able to use strings on this file to find the flag. And if you have some time later, I can show you what I mean. But you can also see that in the solution by Greg. Yeah, I think he opened it up in a hex editor and saw the flag. All right. So I will move on to the last challenge, the binary exploitation challenge. It's called Internet Talk. Check out my lead speed converter. It helps me talk like an internet nerd. Connect via this netcat command, and you can download the binary here. if you've never done a binary exploitation challenge, usually you're given some kind of binary. Sometimes you're also given the source code that you have to analyze and find a way to craft a payload that you can then send to to the binary that's been compiled from the source code, and modify the memory of that uh, you know around around how the binary is running, and be able to make it do things that it wasn't supposed to do. And most often you do it through most often these vulnerabilities come through insecure um, input methods, where if you it only allocates a certain amount of space for your input, and if you provide a lot more input than it expects, it's going to start overriding the stack, and sorry, I'm really sleep deprived, but I'll just move on to the challenge. So once this binary is compiled, you can run it, and we give you the copy of it so you can run it locally. But we often put the flag somewhere else on the disk because we don't want to give you the flag in the binary, so you can't reverse engineer it. And so the reason we give you this netcat command is so that you can connect to the same instance of the binary over the internet, and execute your payload against that, and then read the flag file that's on the actual challenge server that we host. And so NC stands for netcat. It creates a simple TCP socket connection, and so I can demonstrate how that works. If you just simply paste the command, it's going to connect to this host. I'm going to type a command, and it's going to tell me that in lead speak, this is how you do it. Yeah, so we have to find a way to enter some kind of special payload right here to make this program give us, execute a different function. So there are a few different ways you can analyze this binary. You can use a tool like, yep, Steve DeFried comment. It's true. You can use a tool called objdump to, I guess, disassemble the binary. So when you compile a binary, you take the source code and you convert it to instructions that a machine processor can understand, and that's called assembly. The processor can't quite read the assembly, and so you have to convert it to, well, okay, I mean, it's not even once you convert it to like opcodes and bytes, the processor still can read that either. It has to use microcode, to convert further. But assembly is still human readable representation of what's happening. And so you take this assembly and then you essentially, I guess, package it, compile it, convert it into just bits and bytes that look like gibberish, but they tell the machine what to do. They tell the processor what to do. And a tool like objdump is going to take this gibberish and convert it back to assembly. So this is called disassembling. It doesn't tell you exactly what the original source code was. It only gives you the machine instructions in a more readable way, and I can show you that if I just download this file and I do objdump -d, I think. Wait, permission denied. What did I try doing? What? Oh, I'm trying to write to the device that I mounted a sudo. I'm just going to change to the folder I created earlier. Yep. Yep. And so it takes in, if I just do, if I try opening this binary as a file, it's not going to look like anything. But if I pass it through a disassembler, it's going to tell me kind of what the different bytes mean. So for example, right here, I'm pushing a value from the stack onto the EAX register. Here I'm calling the function at this address, which is the string copy function. If you've been doing this for a long time, this will give you enough information to solve the challenge. But there are some other tools that will take this a step further and actually convert it from the assembly back to the original source code. You can't convert things directly from assembly to the source code because you do lose some information when you convert from the source code to assembly. But there are some tools like IDA-Pro, like Ghidra, that will do their best to kind of guess what the original source code was. And so Ghidra is a free tool published by the government, so it's up to you if you want to trust it. But if you load the binary into Ghidra, it will kind of tell you what the original source code was. So here I'll start at the entry point, and it starts the main function at this address. And what this does is it has some variables. And then it prints. Let's see. Let's see what this function is. So it says the buffer. I think this is, we include this in CTF challenges so that the output of the programs isn't buffered, because if it's buffered, sometimes SOCAD or XIND or other tools that we use to show the output of the program, send it over the network, sometimes it gets buffered, and so it's not sent to you immediately, and it breaks things. So this is not part of the challenge, but it's part of part of the infrastructure that we use, part of the design that we use to host these challenges. But if I go back and look at the next function, it prints enter a string to Speakify, and it uses fgets to take in your input. So once it uses fgets, it then uses printf to simply print your input. And so this is where the vulnerability lies. If you've ever done any kind of programming, you're probably familiar with the concept of string formatting. Python has it, Java has it, PHP has it. Well, I'm sure it has it. C definitely has it. And what it does is it gives you an ability to, I guess, concatenate variables in a neater way than to simply, using plus symbols to just string them all together. And it also gives you the ability to kind of format how these variables are represented in the string that you're trying to generate. So for example, if in Python, if you're trying to add an integer in the middle of the string, you might use the %i symbol to say that, hey, I want to place an integer right here. Or you might use %s to say that, hey, right here is going to be a string. C has a lot more things you can put in as you can format. You can put integer strings, but you can also put memory addresses. You can put hexadecimal representations of variables. You can put you can crop or modify or do all kinds of things to these strings. The issue here is that usually when you use format string, you might let the user specify what the second and third and the fourth parameter are, so that their input gets parsed into format string. But in here, the actual format string function that gets formatted can be specified by the user. And so this gives us the ability to read memory addresses and eventually both read and write things to memory. And so essentially what we have to do for this challenge, if you look through the file a little bit more, you will see that there's a a special function at the address, I think 1F9 for, let's see, 491F6. Let me find it. Okay, I'll just page up. 491F6 right here. And what this function does is it opens up the flag.txt file and reads the value. I assume it reads the value of this file and it prints it. Yeah, and so you have this function in the program that already exists that essentially would print the flag for you, but this function is not called anywhere in the program. And so the challenge is for you to use this format string vulnerability to get to this function, to execute this function. And we can do that by overriding something called a GOT, which is the global offset table. Essentially, there's a table that lets you, I guess, link kind of other files and other functions to certain memory addresses. And what we have to do is point one of the entries on the table to this function. I'll try to go into some of the details. I'm not going to go into all the details of the solution, partially because binary exploitation is not my strong suit. So I probably wouldn't be able to solve this challenge myself within the 2-hour period. So maybe next time when we do the solution, I'll bring in somebody who knows binary exploitation better. But secondly, it's a pretty complicated topic that I don't know if we have time to kind of cover all the details of it. But yeah, so essentially what we have to do is do something that's called a global offset table override, or GOT override. And the reason it's doable is because we have this dynamically linked function that already exists. And so I think what we're trying to do is rewrite. So if we look at the output of Giter again, right after we specify original input, there is another function called printf that gets executed. And what we're trying to do is overwrite the value of printf to the address of the win function that we found earlier. And this address is the address that I was just showing a few minutes ago. Of the function that reads the flag. Yeah, and so there is a Python library called PwnTools that lets you do all kinds of things on, with assembly, with binary data that is mostly designed for solving binary exploitation challenges and sending data to them. And so what we're doing here is we're specifying the address of the I'm going to call it the win function because that's what it was called in the source code, but it's also kind of a convention of that you use in CTF challenges. The win function is the function that you need to find a way to run to give you the flag. We use this. We specify the location of the binary locally, and the reason we do that is because we want to pull out some information from it. So we're going to load it into PwnTools. So that we can then reference it and find the address of GotPrintf function. And then we're going to use the format string payload function from pwnlib format string suite. And let's take a look at the documentation to see what it does. Yeah, so it essentially lets you generate payloads where you specify a certain offset, and the offset is um, I guess the location that you're trying to write to. Um, if you look at the solution, the way you calculate that offset is you simply specify use the %x symbol to print out chunks of memory, and then you start see the first few values are not going to be interesting, but then at some point you're going to start seeing the actual %x symbol being shown as part of it, and so this is what you're after. And then you specify the dictionary of the addresses and values that you're trying to overwrite. And we see that in the solution. We're trying to take the address of the printf function from the binary that we're given, and then we're replacing it with the address of the win function. We use this function to generate the payload. If we print the payload, it's going to have a bunch of, I think, like $signs and X and H symbols that, I'm not familiar with this, but let me find some kind of resource that might be helpful. Let's see. Yeah, so for example, you can use the printf has this functionality that lets you index an arbitrary argument. I'm not sure what indexing an arbitrary argument does. Index 2. Okay, that makes sense. Yeah, so you can see right here that we use this %x to print information from the stack. And I think this can be used to just simplify, not quite, but make this string a little bit shorter, not shorter. Sometimes you don't have that many characters in your payload, and it can, I think, let you achieve a similar effect to this, but with fewer characters. So what what this function is doing is it's generating a payload that that contains characters like that, that connects to our problem host on this port using the remote function. It reads the first line, which doesn't have anything. It sends our payload, and then it receives all the rest of the lines from the machine. And if we execute this function, I have the solution script already loaded. I made it so it actually prints the payload string, so you can see it right here. And then it prints this chunk, prints a bit of chunk of memory, and then it executes the function that we're after right here. Yeah, so I think this covers all of the solutions. If you have any questions, if you want to see a more thorough binary exploitation solution for this challenge, let me know, and I can get the person who wrote this challenge to kind of chime in and maybe explain some things a little bit better. But you can send me an email to roman@metactf.com. Our next Flash CTF is going to be on May 24th. So you can join by going to mctf.io/May 2024. I'm going to paste the link in the chat. Yeah, I hope to see you in May. If you're planning to be at RSA, ShowMeCon, besides Buffalo, RVASec. We're going to be at all those conferences doing a CTF there, so feel free to join. Yeah, thanks, Chatter Bob. I honestly feel like you might have been one of the only like 3 people watching. So thank you for keeping me company during this. But I hope to see you all next month or next week if you're going to be at RSA. And yeah, once again, just feel free to let me know if you have any questions. Thanks, everyone. Yep. It's an it's yeah, I really can't speak. But see ya. Thanks. Bye, everyone.